Greetings, math friends. I'm going to look at solving this equation that involves the irrational number e as the base number in this exponential form. The first thing that I'm going to do is I'm going to move the 17 over to the same side. And once we do that, we can notice that this has a quadratic form, where this one is squared, this one is singular, and then this one is to the 0 power. It disappears. To further illustrate that, I'm going to do a u substitution. If I take the e to the x out and I put a u in, I have u squared plus 4u minus 17 equals 0. So it's the same thing. I've just substituted u in for e to the x so that I can see that this has a nice quadratic form. Now that I know that it has a quadratic form, I'm going to put the values of 1, this will be my a value, 4 for my b value, and then negative 17 is my c value into Sridhar-Acharyya's formula. Once we simplify that, if we're solving for x, we're going to take the natural log of both sides. Because what we're really saying is that e to the x, or u in this case, is equal to negative the b value plus or minus the square root of this b value squared, so that's 16 minus 4 times a times c, which is being multiplied by negative 17. And that's all over 2 times a, which is just 2. So this is just Sridhar-Acharyya's formula since I have a quadratic. And the base value was e to the x. That's what we put in for u. So instead of this being x is equal to this, it's e to the x is equal to this. And we solve as normal. This goes to 84. The square root of 84 is 2 root 21. This has a even value in each location, so we can divide that out by 2. So this is going to go to 1, this will go to 1, this will be a 2. So this leaves me e to the x is equal to negative 2 plus or minus the square root of 21. If we separate this out into two separate terms, which I'll do up here for more room, we'll see how to finalize solving for x. I've split this e to the x into its two values that it can take on. We can have negative 2 plus the square root of 21, or we can have negative 2 minus the square root of 21. To solve either of these for x, we're going to have to take the natural log on both sides. This one, we're going to take the natural log of e to the x. The power rule brings this x down, and then due to inverses, this goes to 1, leaving us just x equal to the natural log of negative 2 plus the square root of 21. We're going to do the same thing here. So again, the natural log of this is just going to be x. So this is our second x, and it's going to be the log of negative 2 minus the square root of 21. This one does turn out to be a positive number, so taking the natural log of this, we're going to get approximately 0.9488. This one's going to be negative. So what we can do is we can factor that negative. If we factor the negative out here, this will give us a product of negative 1 and a positive real number. The principal log of negative 1 is going to be pi I. And using the product property, I can say that this is plus the natural log of 2 plus square root of 21, which will be the real component. in standard form for a complex number, this will be your a part, and then you'll have pi will be your b part, real, and times I. So hopefully this has been helpful for figuring out how to do an equation that looks like this with the irrational e base there. Cheerful Calculations.